So for today's notes, we will be solving square root equations and inequalities. So they give us a few steps here on how to solve radical equations. And our first step is always to isolate the radical or rational exponents. So if you have some fractional exponent, you can get it on one side of the equation all by itself. We then want to eliminate the radical. And to do that, we have to do the inverse operation. So the opposite of taking the square root would be to square something. And then we solve the resulting equation. Once we get our answer, we then have to check our solution in the original equation to make sure that we have not obtained any extraneous roots. So let's give these steps a try on some of our first couple of examples. So on number 1, we have the square root of x plus 4 equals 100. So we are trying to get the square root all by itself. First of all, we can simplify the square root of 100. We should know the square root of 100 is 10. So what we really have here is the square root of x plus 4 equals 10. All right, we then need to get the square root by itself. That's our step 1, is to isolate the radical or radical exponents. So I would need to move the 4 over by subtracting. So if I subtract 4 from both sides, I end up with the square root of x equals 10 minus 4 would have given us 6. All right, step 2 is to eliminate the radical or the square root. And to do that, you do its inverse operation or opposite operation. The opposite of square rooting something is to square it. And if you do something to one side, gotta do it to the other. So the square is just gonna make the square root go away, so we're left with x. And then I have 6 squared, which is 36. So we have solved for x. Now, it does say that once we have done so, we need to check our answer in the original equation to make sure it's not extraneous. So I'm going to have to take this 36 and plug it in for x in this equation up here. So if I plug this in for x, I would end up with the square root of 36 plus 4 equals the square root of 100. So we know that the square root of 36 is 6. So I would have 6 plus 4 equals the square root of 100, which we already have said is 10. And 6 plus 4 is 10. So I have 10 equals 10, which is true. So this one worked out for us. All right, let's give this another try. So number 2, first step is to get the square root or the radical all by itself. So I'm going to need to move the 8. I subtract 8 from both sides. So I end up with the square root of x plus 1 is equal to 2 minus 8, which is negative 6. And to get rid of the square root, we square it. Got to do it to both sides. So we are then left with x plus 1, since I've made the radical go away. Then I have negative 6 squared, which means negative 6 times negative 6, which is positive 36. And then we solve. So I need to get x by itself. I subtract 1. I end up with x equals 35. All right, I now have to check this in the equation to see if it works. I'm going to take this 35 and plug it into the original. So I'm going to have 8 plus the square root of 35 plus 1 equals 2. So we do what's underneath our square root first. 35 plus 1 is going to give us 36. So I have the square root of 36. Well, we know the square root of 36 is just 6. So this just becomes 8 plus 6 equals 2. Well, 8 plus 6 is 14, which does not equal 2. So this one would be an extraneous root or solution. All right, number 3. So there's nothing to move. So we have already gotten the radical by itself. We now need to get rid of the radical or the square root. So we're going to do that by squaring. So the square makes the square root go away. We now have 12 minus x equals 0 squared, and 0 times 0 is just 0. Now we need to solve for x, so I subtract 12 from both sides, and I have negative x equals negative 12. I don't like my variable to be negative, so I'm going to divide both sides by -1, which just makes them both positive. All right, now we are going to check that 12 in the original to see if it works. So I would have 12 minus 12 underneath the square root is equal to 0. Well, 12 minus 12 is 0. So I would have the square root of 0, and the square root of 0 is 0. So this one works. So basically, all we have to do is solve for x. Once we get x, plug it in and see if it works. Let's try a few more examples. All right, number 4. We have radicals on both sides, and they are all by themselves, so nothing to move. So we move on to step 2, which is to get rid of the radical or the square root. And to do that, we have to square both sides. So squaring those just makes the square root go away, which is going to give us 5 plus 7x equals 5x minus 9. And we are trying to solve for x. So I need to move the x's to the same side and the numbers to the same side. So I'm going to subtract 5x, which is going to give me 2x. And then I am going to subtract 5 from both sides, which makes this go away. -9 minus -5 is -14. I divide by 2, and we get that x equals -7. All right, now I'm going to plug this into the original and check it. So I would have the square root of 5 plus 7 times -7 equals the square root of 5 times -7 minus 9. So what I would have under here would be 5, and then I would have 7 times -7, which is -49. And in this one, 5 times -7 is -35 minus 9. So we had to do the multiplication first because order of operations says to do multiplication before addition or subtraction. So now I have 5 minus 49, which is going to give me the square root of -44. And over here I have -35 minus 9, which is also going to give me -44. So this one works. All right, number 5. So the first thing we need to do is get this radical by itself. So I'm going to move the 10. I'll subtract 10 from both sides. And I would now have -4 square root of x equals 16 minus 10 is going to give us 6. And I would then divide by -4. All right, so now I have the square root of x equals 6 over -4, and I want to get rid of the square root. So I'm going to square both sides here. So I would have x equals, now remember, squaring something is like multiplying it times itself, and when you multiply fractions, you multiply top and bottom. So you would have 6 times 6 in the top, which is 36. And -4 times -4 in the bottom would give you +16. All right. Now, we could simplify this. You could have also simplified here, realized that that was going to give you 3 over 2. But at this point, we can realize that we can simplify this by 4 on top and bottom, and this would become 9/4, which is a little bit nicer to plug in. All right, so now I just need to check it. So I'm going to plug it up here into the original. So I would have 10 minus 4 times the square root of 9/4 equals 16. So the first thing we want to deal with is our radical. So I take the square root of both of these numbers. So I can take the square root of 9 and I'll get 3, so copy down the rest. And I can take the square root of 4 and get 2. So now I have -4 times 3 over 2. Remember, you can put that over 1 and multiply tops and bottoms. So I have -4 over 3, which is -12, over 1 times 2, which is 2. So -12 divided by 2. Well, -12 over 2 will simplify to -6. So I have 10 minus 6 equals 16. This is not true. So this answer is extraneous. All right, number 6, very similar to number 4. There's nothing to move, but we do need to get rid of those radicals, and we do so by squaring. So I have 6x minus 7 equals 2x minus 5. Now that the square roots are gone, and we solve for x. So I move 2x over. And then I need to move that 7 over. So 5 plus 7 would give us 12. We divide by 4 and we get that x equals 3. All right, now I just need to take that 3, plug it into the original. So I would have the square root of 6 times 3 minus 7 is equal to the square root of 2 times 3 plus 5. All right, so underneath our square root here, we have 6 times 3 that we would do first, multiplication before subtraction. So 18 minus 7. And over here I have 2 times 3, multiplication before addition. 6 plus 5. All right, now we can subtract. 18 minus 7 is 11, so I have the square root of 11. And 6 plus 5 is 11. So this one works. All right, just a couple more examples. So on number 7, we're going to need to move everything away from the radical. So I start by subtracting 11. 2 minus 11 is going to give us -9. I then would divide by 2. And I'd end up with the square root of x equals -9 over 2. Now I need to get rid of the radical. So I square both sides. Now remember, that means we're squaring the top and the bottom, or multiplying across times itself. So that's going to give you 81 over 4. All right, now we're going to need to plug this in to the original and see what we get. So we would have 2 times the square root of 81 over 4 plus 11 equals 2. Well, I can square root both 81 and 4, which is what I would want to do first, and it would become 9 over 2 plus 11 equals 2. So here I multiply, or I might realize that the 2's cross out. I have 9 plus 11 equals 2, which is not true. So this is extraneous. All right, last example like these. So I need to get the square root of x by itself. This is similar to number 1 because there actually is a square root of 16. So I can rewrite this as the square root of x plus 3 equals 4. I would then move the 3 over and end up with the square root of x equals 1. I now want to get rid of the square root, so I square both sides, and I end up with x equals 1. Now I just need to plug it in and check. So I would have the square root of 1 plus 3 equals the square root of 16. Well, the square root of 1 is 1, plus 3 equals the square root of 16, which we already said was 4. 1 plus 3 is 4, and 4 does equal 4. So that one worked. So just to recap, we always need to get the radical or the square root all by itself. Once you have done that, you need to get rid of the radical or square root by squaring both sides. You then solve for x. Once you have solved for x, always go back and check your answer in the original equation to see if you have an extraneous root. Okay. 2 more examples. So we are still doing the same thing using the same steps, but on these, they give us some real world problems. So our first example wants us to solve the following equation for r. So instead of solving for x, we are now solving for r. They give us that v equals 1/3 pi r squared times h, and they want us to find the approximate radius, which would be our r, of the cone that has a height of 11. So height is our h, and volume of 184 cubic inches. So they gave us a couple things to plug into that equation. So we now know that our volume is 184, so I'm going to replace v with 184. And then we have 1/3 pi r squared. They also told us that the height is 11, so I'm going to replace the h with 11. Okay, so the only thing we are looking for here is r. So I'm going to combine some of these other things on the other side before I try and get my variable by itself. So I would multiply 1/3 times 11, which is just going to give me 11/3 times pi times r squared. All right, so now I'm going to need to get r squared by itself. Right now, 11 pi thirds is being multiplied times r squared. So I'm going to divide by 11 pi thirds to make that go away. But if you do it to one side, got to do it to the other side as well. Now, remember, when you divide by a fraction, we keep, change, flip. So we keep 184. We change from division to multiplication. And then I flip this one over. So 3 over 11 pi. So you can type this in your calculator, or you could type it in just like this. Just make sure you put everything in parentheses. So I'm going to get out my calculator. So in my calculator, we are going to be multiplying 184 times 3 divided by 11 pi. All right, so pay attention to where I put the parentheses because you want it to multiply 11 times pi before it divides by the 3. So we end up with 15.973368883. All right. So we can just go 3 decimal places here. So I would have all of this is what we just typed in, turned into 15.973 is equal to r squared. All right, now I just need to get rid of this square so we can solve for r. The opposite of squaring something is to take its square root. So in my calculator, I'm going to take the square root of that answer, and we get 3.996. And if we were to go 3 decimal places and start rounding, this would be approximately, which they did ask us to just approximate here. I'd say that this is going to be approximately 4. So the radius of the cone is approximately 4 inches. Oops, sorry about that. All right. So radius of the cone is approximately 4 inches. All right, let's do another example. So number 10 says to solve the following equation for x. Again, they give us a volume formula and want us to find the approximate length of the base of the pyramid. So apparently x is the length that we are looking for, and they did again give us 2 things to plug in. They give us the height to be 120 feet and the volume to be 100,000 cubic feet. So I'm going to replace the volume with 100,000. 1/3. X is what we're looking for, so we leave that as a variable. And they did also tell us that the height was 120. So I'm going to plug that in as well. So we have 100,000 is equal to, I want to combine my 2 numbers. So remember, this is like being over 1. So I multiply the tops. 1 times 120 over 3 times 1 times x squared. All right, and our goal is to solve for x. So I'm going to leave that x squared there, and I'm going to need to divide by 120 over 3 to make those go away. If I do it to one side, got to do it to the other. Remember, when you divide by a fraction, you keep change flip. So you would keep 100,000, change from division to multiplication, and flip that other fraction over. So remember, on both of these, keep, change, flip equals our x squared over here. So again, you might want to go back to your calculator. So we would have 100,000 times 3 divided by 120, which gives us 2,500. So this became 2,500 equals x squared. And our last step to get x by itself would be to take the square root. So I'm going to have x equals the square root of 2,500, which is 50. So x is 50, and in the problem, they told us that x was representing the length of the base of the pyramid. So the length of the base of the pyramid is 50 feet. So again, we worked to get the variable by itself. In this case, we had an exponent instead of a radical. We then did the inverse operation of the exponent to get rid of it to solve for x.